Okay, we'll start with problem number 1. In this problem, you'll ask which diagram represents not a function and explain why. Okay, so here we got 3 different mappings and we want to determine which one of these is not a function and also provide the reason why it is not a function. Okay, by looking at this, which one is not a function? Is C. Okay, take a look here. At C, we got -4, and it's paired with 2 different values, 1 and 3. Okay, for it to be a function, only one x goes to only one y. And in this case here, we got an x value to 2 different y values. So, all right, in problem number 1, we can just say that C is not a function, and the reason, we can write something like this. -4 is paired with 1 and 3. Oops, I can't see that. So here graph C is not a function because -4 is paired with 1 and 3. Okay, any questions about problem number 1? All right, number 2 is the use of the vertical line test to determine whether the graph below represents a function. So let me go ahead and draw that graph. That's similar to the one that's on the review sheet. Okay. Now here we use the vertical line test to determine whether that graph is a function. If that vertical line crosses the graph at more than one place, then that means that the graph does not define y as a function of x. So in this case, would this be a function? If I was to draw this vertical line, no, it would not. Here's the vertical line. You can see that that vertical line crosses the graph at 2 different places. So that means that this graph is not a function. Okay. All right. Are there any questions about problem number 2? All right, number 3. For the function f of x is equal to 3x cubed plus 5x squared. We want to find out what f of 4 is equal to. So here I want to find out what f of 4 is equal to. And in this case, we just simply substitute every x in that. This should be -4, sorry. The f of -4. All right, so we just substitute every x with -4 in this function. So f of -4, that would be 3 times x, which is -4, and that's cubed, plus 5 times x, which is -4, and that's squared. And you are allowed to use your calculator, but do make sure that you do bring your own calculator or something to write with, along with your one-page sheet of notes. Okay, so, excuse me. Bring down to 3. If I cube a -4, that's going to be -64. I'm going to bring this 5 down. If I square that -4, that's going to be 16. All right, so here 3 times a -64 is -192, plus 5 times 16 is, I think that's 80. And what's negative 192 plus 80? Negative 112. Okay? So the value of that function when x is negative 4 would be negative 112. Okay? Are there any questions about problem number 3? All right, number 4. Here we got g of x, and that's equal to x squared plus 2x plus 3. And we want to find out what g of x plus 5 will be. So in this case, we're substituting every x in that function, in that g of x function, with x plus 5. All right, so that means here this x would be replaced with x plus 5, and that's going to be squared, plus 2 times that x will be replaced with x plus 5, and then plus 3. And from here, we just go ahead and just simplify. Now, in this case, for that x plus 5 quantity square, I'm going to do this off to the side as scratch work. That x plus 5 is used as a factor twice, so I'll just write that as x plus 5 times x plus 5. And then go ahead and use the FOIL method. So in this case here, x times x, that's the first times the first, that's x squared. Outer, x times a plus 5, plus 5x. And then 5 times x would be plus 5x, and then 5 times 5, 25. So here we got x squared. 5x plus 5x will be 10x plus 25. So that's what x plus 5 quantity squared would be. X squared plus 10x plus 25. Now for the 2 times the quantity x plus 5, we'll just distribute that. It'll be 2 times x, that will be a plus 2x. And then 2 times a 5 was 10. And bring down the plus 3. Now we just go ahead and combine some like terms here. Let's see, I'll bring down the x squared. 10x plus 2x is 12x. And then 25 plus 10 plus 3 is, it's what, 38? So g of x plus 5 for that function would be x squared plus 12x plus 38. Okay. Are there any questions about problem number 4? All right, number 5 is to use the graph to determine the open intervals on which the function is increasing, if any, the open intervals on which the function is decreasing, if any, and the open intervals on which the function is constant, if any. Okay, so this parts A, B, and C. We want to know the intervals on which it's increasing on, decreasing on, and constant. Okay. So sometimes it does help to put the cover the graph with a piece of paper and move it from left to right to see the intervals on which is increasing or decreasing. Now, when we do that, we only use the x values, not the y's, just the x. So if I cover this graph, move it from left to right, well, that arrow tells me going downward, that means it's going indefinitely to the left, so that's got to be negative infinity. And it's increasing It stops increasing at what x value? -4. So from negative infinity up to -4, this graph of this function is increasing. So we can say that it's increasing on the interval from negative infinity to -4. All right, so now from -4, we can see that it's decreasing, and it stops decreasing at what x value? -3. So between -4 and -3, the function is, the graph of the function is decreasing from -4 to -3. And notice I'm using parentheses on these intervals. We always use parentheses. And then after -3, it increases again, and it stops increasing at what x value? -2. So between -3 and -2, the graph of that function is increasing. I'm going to do this union, -3 to -2. And after -2 is doing what? Decreasing from -2 on to infinity. So from -2 to infinity, it's also decreasing. And
the parentheses on the numbers because there's no dot.
well, we're not including where it reaches its highest point. Okay. We're not including the highest point and the lowest point on the graph. That's why. That's why we use parentheses. And for it being constant, you can just say none.
Why wouldn't it be negative?
Which one?
Like the second one, like after the -2?
Because we're going from left to right. Okay? We're going from left to right. That means we're just looking at the x, not the... Okay? Any other questions about number 5? Okay. Number 6 deals with relative maximum and relative minimum. So here the graph of the function f is given, and you want to use the graph to find each of the following. The numbers are the x values, if any, at which f has a relative minimum, and what are those relative maxima, I should say. And then part B is just a relative minimum, the x values, and then what would be that relative minima, or minimum. So with this one, let's start with part A. We want to find out where the relative maximum occurs. That means we're trying to find that x value itself, and then the relative maximum would be your y value. Yeah, because you want the x value for which it has a relative maximum, and then they ask for what is the relative maximum, which is going to be that y value. All right, so by looking at this, let's see, the highest point here would be right here. Now, what would be the x value for that relative maximum? -1. That's where that relative maximum occurs. So the relative maximum occurs at x equal -1. Now, by looking at this, what would be the y value for that relative maximum? 2. So the relative maximum is 2. All right, questions about part A. Now, of course, part B asks for the relative minimum. So we're going to find out the x value where the relative minimum occurs and what would be that relative minimum, which is, of course, the y value. Okay. So by looking at this graph, here are your two lowest points, here and here. And what are the x values where that relative minimum occurred?
-2 and 1.
-2 and 0. Yeah, because here's the y-axis right here. That point's on the y-axis, so that x value has to be 0. So the relative minimum occurs at x equal -2 and x equals 0. And then for the relative minimum, we look for the y value for that. What's your y value for that relative minimum?
-2.
-2. Okay. Okay. Are there any questions about number 6? All right, number 7 is a piecewise function. So here for the piecewise function, which is, of course, f of x is equal to, now we only use the -2x plus 3 when x is less than 4, less than or equal to 4. We use only the 3x if your x value is greater than 4 and less than or equal to 7. And then, of course, 5 if your x value is greater than 7. So that's our piecewise function. So we're going to use that piecewise function to find f of 4. And also f of 234. So for f of 4, which one do we use? The one on the top or the middle or the bottom? The one on the top. Because it says x is less than or equal to 4, and we do have the x value of 4. So we use the -2x plus 3. So it'll be -2 times x, which is 4, plus 3. -2 times 4 is -8, plus 3 is -5. So the value of that piecewise function when x is equal to 4 would be -5. Okay. And then for f of 234, which one did we use? The first, the second, or the third? Third, because that 234 is greater than 7, so f of 234 would just be 5. That's all there is to it. Okay. Are there any questions about problem number 7? Okay. In problem number 8, you're to determine whether the function is even, odd, or neither. So in this case here, number 8, we have this. We have the function f of x is equal to 3x cubed minus 6x plus 1. Here we want to determine whether that function is even or odd or neither. So in this case here, we find out what f of -x is. We have to replace every single x in that function with -x. So it'll be 3 times negative x, and that's going to be cubed, minus 6 times, replace the x with negative x, and then plus 1. And then we simplify this. Anytime we cube a negative, that's going to end up being negative. So it'll be negative 3, and that x will be to the third. Minus 6 times negative x will be plus 6x, and then plus 1. Now you're going to compare that to what f of x is. For it to be even, you must get the original function that you started off with after replacing the x with negative x. For it to be odd, every single term in that function must change to the opposite sign. In this case, it's neither, and here's why. Only the first and the second term change to the opposite sign, but the third term, that plus 1, remain the same. Every single term must change to the opposite sign in order for it to be odd. And it's not even because we didn't get the original function that we started off with. So this function is neither odd nor even. Okay. Questions on problem number 8? All right, problem number, yes.
If none of them change, would it be odd here? None of the signs change after.
For it to be odd, every single term has to change to the opposite side. Any other questions? All right, number 9. Here we're finding the domain of this function f of x is equal to 2x to the third plus 9x squared plus 7x minus 4. The whole thing is divided by x squared plus 4x minus 12. What type of function do I have here? Or who remembers what type of function do I have? Do I have a polynomial function, a rational function, or a radical function? Rational, because I have a numerator and a denominator, and there are variables in the denominator. So that means here, I will have to take what's in that denominator and set that equal to 0. So that means I'll take x squared plus 4x minus 12 and set that equal to 0. Well, notice I have a polynomial equation that I'll try to factor into 2 binomials here. Let's see if we can do that. That x squared breaks up as x and x. Now, what factors of a minus 12 will give me 4x as a middle term? 6 and 2. Now, the larger of the 2 factors will have to take the sign of that middle term. So that 6 will have to be plus, and the 2 will have to be minus. So I have x plus 6 times x minus 2 equal to 0. And then we set each binomial factor equal to 0. So that means that x plus 6 is equal to 0, or x minus 2 equals 0. And then solve each equation for x. So for that x plus 6 equals 0, x is equal to negative 6. Or for the x minus 2 equal to 0, x is equal to 2. So at negative 6 and at 2, I would get a 0 in the denominator. And for that problem, you'll be asked to give your answer in interval notation. Now, this helps, and you're not required to do this, but if it helps, you can draw a number line and put negative 6 and 2 on it. Negative 6 is here, 2 is here. We know at negative 6 and at 2, we will get zeros in the denominator. So I'm using parentheses around those. Every x value less than negative 6 would work for that rational function. Every x value between negative 6 and 2 would satisfy that rational function. And every x value greater than 2 will satisfy that rational function. So that means here, the domain in interval notation would be this. Going from left to right, it would be from negative infinity up to negative 6. And in parentheses, negative 6 to 2. And also from 2 to infinity. Okay. All right. Any questions about problem number 9?
We don't do the range.
No. Yes.
If I'm not mistaken, I feel like on the homework it was one where on a number line it will only be one number. Was it always two numbers? Was it always two numbers? I feel like it was one point. It was like one number. I didn't know. I didn't know how to put that number.
Okay. I have to look at it and see. We'll have to talk about that after class. Okay. All right. Any other questions? Okay, so that's problem number 9. Number 10, also they ask you to find the domain. And here this is f of x is equal to the square root of 84 minus 6x. Now what type of function do I have here? A radical, because I got that square root, so that's a radical function. And to find the domain of any radical function, you take what's underneath that square root. And this is to an even power, by the way. I mean, even index. We set that to be greater than or equal to 0. And get x by itself. So what do I need to do to get x by itself? Let's subtract 84 on both sides. So that means negative 6x is greater than or equal to negative 84. And then when I divide both sides by negative 6, what's going to happen to that greater than symbol? Switches from greater than or equal to less than or equal to. And negative 84 divided by negative 6 would be 14. So that means any x value less than or equal to less than or equal to 14 would satisfy that radical function. Okay, so if we were to do this in interval notation, let's see, 14 is to the right-hand side of 0. And do I need a bracket or parentheses? Bracket, because it's less than or equal to. That means 14 will be included. And any x value less than 14 would work for this radical function. So the domain here would be from negative infinity up to 14. And we do include the 14, so that's why I have the bracket there for the 14. Okay. Any questions on number 10? Okay. Number 11 is the algebra of functions. And with that, all you'll be asked to do there is just find the sum, the difference, the product, and the quotient of those two functions, f and g. Don't worry about finding the domain. So here we're given that f of x is equal to 2x minus 25, and g of x is equal to 3x plus 7. So here we're going to find the sum of those two functions, starting with f plus g of x. That's part A. And that just simply means f of x plus g of x. So here we replace the f of x with that 2x minus 25. Then plus g of x, that's 3x plus 7. So all we do here is just simply combine like terms here. 2x and 3x is 5x. And then negative 25 plus 7 is negative 18. So the sum of f and g of x would be 5x minus 18. And that's all there is to it. Okay. Questions about part A? All right, part B is the difference of the two functions f minus g of x. That means f of x minus g of x. So here f of x is at 2x minus 25 minus, now g of x is at 3x plus 7. And I see this happen so often where people don't put the parentheses around the entire g of x function because the entire g of x function is being subtracted from f of x. Okay? So make sure you put the parentheses there when you're subtracting. And then the minus sign will make the 3x minus 3x, and the minus sign makes the plus 7 minus 7. Now, what's 2x minus 3x? Negative 1x, or just negative x. And now negative 25 minus 7. Minus 32. So here, the difference of f and g of x will be negative x minus 32. Okay, so that's part B. Part C is, of course, fg of x, the product of the two functions, which means f of x times g of x. And, of course, f of x is at 2x minus 25, and g of x is 3x plus 7. So with this one, we'll have to use the FOIL method. And that's going to be this. The first times the first, 2x times 3x is 6x squared. The outer 2x times that plus 7, 14x. And then the inner minus 25 times 3x is negative 75x. And then minus 25 times 7. That's what, minus 175. Okay. So now, bring down that 6x squared. 14x minus 75x is how much? Negative 61x, and then minus 175. So the product of f and g of x is 6x squared minus 61x minus 175. Okay? So that's going to be part C. And part D is the quotient of f and g of x. And that simply means f of x divided by g of x. And here f of x is that 2x minus 25 divided by g of x is 3x plus 7. And that will be as far as I will be able to go with that problem, because I'm not going to be able to factor out anything and divide out any common factors in the numerator and the denominator. All right, any questions about problem number 11? Okay. All right, problem number 12 is the composition of two functions, f and g. You'll be finding the composition of f with g and the composition of g with f of x. So in problem number 12, you got f of x equals to 5x minus 23. And you got g of x is equal to 4x plus 1. And we'll start with the composition of f with g of x. And that just simply means f of g of x. So that means your inside function is g of x, whereas the outside function will be f of x. All right, so here, your g of x, that's going to be that 4x plus 1. So I'll bring down this f and replace the g of x with what is equal to 4x plus 1. So I'm going to find out what f of 4x plus 1 will be. But of course, I know what f of x is. That's going to be the 5x minus 23. So that means for every x in this f of x function, I'm going to substitute it with what g of x is. So that means this x will be replaced with the g of x. That's going to be that 4x plus 1. And in that 5x minus 23, that x will be replaced with what g of x is, 4x plus 1. And in this case here, we'll just simplify that right-hand side. So here, 5 times 4x, that's going to be 20x plus 5 times 1, 5, and then minus 23. And then what's 5 minus 23? Negative 18. So the composition of f with g of x would be 20x minus 18. Are there any questions about part A? Now part B is the composition of g with f of x. And that's just simply going to mean g of f of x. So this time, f of x is your inside function, whereas g of x is your outside function. And I know what f of x is. That's going to be 5x minus 23. So I'll replace this f of x with what is equal to. So I'm going to find out what g of 5x minus 23 will be. Okay. But of course, your g of x is that 4x plus 1. So for every x in g of x, I'm going to replace it with what f of x is. So that means here, this x in the g of x notation will be replaced with f of x, which is 5x minus 23. And in the 4x plus 1, that x will be replaced with 5x minus 23. Okay, next we'll distribute and combine like terms. 4 times 5x is 20x minus 4 times 23, which is 92. And then what's negative 92 plus 1? Negative 91. So I end up with g, the composition of g with f of x equaling to 20x minus 92. 1. Okay. All right, any questions on number 12? All right, number 13 is decomposing two functions, f and g. So here we got the composition of f of g of x, the inside function is g of x. That's equal to 5 divided by the quantity x squared minus 3x plus 6. That's going to be raised to the 6th power. And we want to find out what f of x started off as and what g of x started off as. And of course, your g of x is your inside function. Okay. Now, in this case, this is what I'm going to do here. What's inside the parentheses? That x squared minus 3x plus 6. I'm going to let that be g of x. So that means g of x will be x squared minus 3x plus 6. And then what's left will be f of x. Since that x squared minus 3x plus 6 was put in place of x in the f of x function, that means f of x had to start off as 5 divided by x to the 6. Okay, and you can check by replacing this x with that x squared minus 3x plus 6, you'll get this back. Okay. So f of x was 5x over 6. 5 to the x to the 6. 5 divided by x to the 6. G of x is x squared minus 3x plus 6. Okay. Any questions about problem number 13? Yes.
Regardless of if that is at the numerator will always be g of x, and it's x squared minus 3x plus 6.
Yeah, because the inside function is g of x. Okay, because notice here how it's written. That g of x will be inside function. So it will have to be that x squared minus 3x plus 6. Okay, any other questions? All right, problem number 14 is finding the inverse of a function, like f of x equal 9x plus 23. F of x equal to 9x plus 23. And here I want to find out what that inverse is going to be. Well, the first step would be to replace your f of x notation with y. So here we're going to have the y equals 9x plus 23. And then the second step would be to interchange x and y. So that means that this y becomes x, so it'll be x is equal to, and that x becomes y, so it'll be 9y plus 23. So here I got x equals 9y plus 23. And then step number 3 is to solve that equation for y. So I need to get y by itself by doing what? We'll start by subtracting 23 on both sides. So this will be x minus 23 is equal to 9y. And then to get y by itself, we divide by 9. So that means y is equal to x minus 23 divided by 9. And then the final step would be to replace the y with this notation. F inverse of x. So F inverse of x will be equal to x minus 23 divided by 9. Okay. Are there any questions about problem number 14? Okay, and finally, number 15 is using a horizontal line test to determine if the graph below has an inverse. Okay, so let's say we had this graph, and I'll draw similar to the one that's on this review sheet. Okay, so that's x, and this is y. Horizontal line test helps us determine whether the graph of that function has an inverse. So would this have an inverse if I draw that horizontal line? Yes, it would. Because that horizontal line only crosses the graph at one place. If it crosses the graph at more than one place, then it would not have an inverse function. But since it only crosses the graph at one place, there is an inverse function for it. Okay? And don't be drawing a vertical line when it says use a horizontal line test. I see students do that all the time. Or someone does that, draw that vertical line when it says use a horizontal line test. Okay, are there any questions about what will be on your second exam? And it will be, yes, it's not. Okay. Any other questions? Okay, so your second exam will be when we come back from this inclement weather, because I'm hearing that the temps on Thursday, even after we get the snow, it probably will not get above freezing. So what's on the ground is going to be stuck on that ground for a while. So I'm assuming it will be back next Tuesday, but I will keep you posted. Okay. Anything else? All right. Make sure you sign the sign-in sheet if you haven't already done so, and I will see you when we get back.
I ended up figuring it out once we did the radical. I didn't realize it was a difference, so I figured out once we did it.
Okay. All right.
They just didn't calculate your activity still up, because I wasn't able to see because my internet ain't working at home.
Number 2 or number 1?
Number 2.
I haven't opened it yet.
Okay.
Let's see. 12. Okay.
Sir,
Hmm.
I was just talking to myself.
Oh, okay. It's all right.